Hi guys, and welcome to another MaffsGuru video, but this time on angles of elevation and depression, bearings and triangulation. Sounds like a lot of stuff, yes? Well, believe it or not, you already know much of the theory beforehand if you've watched my previous videos. Now, they are all on MaffsGuru.com and are there searchable by textbook, by chapter, and with downloadable notes for your summary book or exercise book. I'm doing my best to help you. Maybe you can help me by subscribing to my YouTube channel or giving me a shout out on TikTok to drive people over here, because trust me, I am doing my best and hopefully just want to help as many people as I can. Never going to be rich and certainly never going to be famous. Thank you. To recap those videos, if you remember, when we have triangles, there are certain elements of theory or certain areas of theory that we can use to help us find missing angles or missing side lengths. So for right angle triangles, we have Sokatawa. I don't know why I said it that way. My apologies. Yes, where we have these identities to find the sine of an angle, you have the opposite over the hypotenuse, cosine of an angle, adjacent over hypotenuse, and tan of an angle is opposite over adjacent. And again, that was given by a right angle triangle, and it had to be a right angle triangle where if we had a theta here, that became the opposite, that became the adjacent, and that became the hypotenuse, right? And then we could use our calculator. Then there was the sine rule and the cosine rule. Now, both of these dealt with non-right angle triangles, where effectively we had values of A, B, and C, and that would be angle C, that would be angle B, and that would be angle A. And then we could find out various information relating to sides or angles, depending on what the question actually gave us. So a sine rule, if you remember, they had to give you a side and an opposite angle, and then one other piece of information. And for the cosine rule, it was two sides and one included angle. Now, how are we going to apply this stuff? Well, basically, angles of elevation and depression are just a huge trick. It's Pythagoras, but in disguise. So I always think about elevators as going up. I know they go down as well, but I generally always take them up. Never want to walk upstairs, happy to walk down them, never up. Okay, so elevators go up, and sadly, when I'm feeling a bit depressed, I'm feeling a bit down. Now, this isn't a great example because depression, not a great thing to suffer from. Trust me, I've been there, done that, and bought that very big t-shirt. So if at any point this year you are feeling down, there are people you can reach out to, your teachers, your mentors, your heads of house, family. Talk to someone. It doesn't matter what you feel you are going through. Talk to someone that they can help, okay? I was very lucky. I had someone to talk to, and I think it's the reason I am still here today. So yeah, I know what we're talking about. But anyway, depression makes me feel down. So what is this all about in terms of maths? Well, angles of elevation start from the horizontal and go up. So if here is a horizontal, I could be lying at this point here, and if I'm going to look and have an angle of elevation, then basically it is this angle here. So it's starting at the horizontal and going up. Now, weirdly, angles of depression and angles of elevation are also the same, but we'll come back to that in just a moment. Angles of depression start from the horizontal and go down. So for example, there is the horizontal. That could be me on the top of a cliff, and I could be looking down at something in the sea. This angle here is an angle of depression. Now, if you remember any of the angle rules, and the ones that most people tend to work out here is the physics rules here, which is that this angle in the corner there and that angle in the corner there are identically the same. So funnily enough, this angle here is an angle of depression, and this angle here is an angle of elevation. And so long as we look at the diagram and it's drawn that way with parallel lines, they're exactly the same thing. Now, don't press stop, not just yet, guys. This is a preview video and you've reached almost the end of it, but it does continue over on MaffsGuru.com. MaffsGuru.com, yep, that's my custom website. Bits of it you can see around me at the moment. That has been designed to allow the videos to be easier searched than they are on YouTube. So you can search by chapter, by textbook. Each video has downloadable notes for you, so you can put them in your summary book or your exercise book. There are exam questions, and there is more and more content and more stuff coming as time allows. So head on over there. It's absolutely free to sign up, and I'm doing everything I can to make sure that you guys enjoy maths and actually take out the mastery of maths. It is not as hard as you think. It is all smoke and mirrors. Okay, thanks very much. Take care, guys. I look forward to seeing you in another video. Stay safe.